Quality Control and Improvement, Module 2, Lecture 1, Monitoring Process Quality. So learning objectives for Lecture 1 are construct and interpret stem and leaf displays, box plots, and histograms. Given the data set, we want to compute the sample mean, variance, and standard deviation, and the range of the data set. The reading assignment is Chapter 3, pages 65 to 75. There are several graphical methods that are very useful for summarizing and presenting data. Each of them has specific advantages. There's a stem and leaf plot, there's a box plot, and the histogram. In my opinion, I found the histogram to be the most useful, but the other ones, the stem and leaf plot and the box plot, do have some uses and some advantages. First, let's talk about the stem and leaf display. When using a stem and leaf display, each data value is split into a stem and a leaf. Typically, the stem has the first digit or couple of digits, and the leaf usually contains the last digit. The stem and leaf plot has 3 columns representing the counts, stems, and leaves. And we'll take a look at a practical example using Minitab. So let's use Minitab to make a stem and leaf plot of the following data set. So let's look at this first example in Minitab. I've went ahead and pre-typed in the data, just as you've seen right from the problem. You don't have to sort it. These numbers, when you want to plot it, you can if you want. You can actually click on the column and click sort column, and it will sort however you want. In this case, we really don't really have to do that for the stem and leaf plot because Minitab will take care of it and plot it for us. So to plot the stem and leaf, you go to Graph, go to Stem and Leaf. Now, typically the graph variable will be empty, and it'll show us in the first column here, row here, it'll show what we have here, C1 in data. So click on that, click Select. You can leave the variable in the increment blank, click OK, and you can see the stem and leaf plot is shown here. If this isn't blown up enough, you can come down to the lower right-hand corner. You can click the plus and minus to either shrink or blow this up. I usually blow it up so I can actually see it. So here's the information. So it shows you have 11 pieces of data, which corresponds with our number of data that we wanted plotted, 1 through 11. You see it's composed of 3 columns. The first column is the count, the second column is the stem, and the last column is the leaf. So here, for example, in the first row, you have 1 and a 2, that's 12. How do I know it's 12? Because I look at the leaf unit. The leaf unit shows me what sort of where the decimal place is. So these are kind of like ones position. If this had been a 0.1, it would have been 1.2. But since it's 1, this shows that we have a 12 and a 14. And there's 2 elements in this row. Now, you kind of look at the first column for the counts, and it kind of looks kind of confusing. Well, where'd the 4 come from? Because here you have a 15 and the 16. What this is counting the amount of numbers up to the median, which is shown here in the parentheses. The median is in this row, so it's either 23 or 24 is the median. And also, if you go down to the numbers below the median, the last number, it shows there's 1 of these. That's 48. There's none here, so that's you still keep a 1. That's why it didn't increment. And then here you have a 36, so you have 1 number here and 1 number here that adds up to the 2, and it continues to increment until you get up to the median. So here there's 5 entries from 25 down to 48. So you got 25, 2 25s, a 27, a 36, and a 48, which makes 5. And you got 4 entries less than the third row. There's 15, there's 16, there's 12, and there's 14. So I hope this helps you. If you need help, just post a message in the discussion group. Let's just take a look at the box plot. The box plot is a graphical display that simultaneously displays several important features of the data. First of all, here's a plot of showing a box plot of a data set. The median is represented by the line in the box. So here it appears to be around 70 in this example. Approximately the middle 50% of the data falls inside of the blue box. The whiskers extend from either side of the box up to the last data point. So this for example, here, this top whisker represents the top 25% of the data values, and the bottom whisker represents the bottom 25% of the data values. So let's look at a practical example, example 3.4. He has some data for hole diameters and wing leading edge ribs. And so he has 12 data points. And so the book shows the plot, the box plot kind of laying on the side. Minitab doesn't really plot it this way. But again, we'll look at it in Minitab in the next slide. But so here's the median. It's 120.6. Here's what's known as the first quartile, 120.35. Here's the third quartile. And the whisker extends from the third quartile to the last value. And this whisker extends from 120.35 back to the first data point. So let's take a look at this in Minitab. Let's look at the example with the box plot. So I've entered the data in the table in column 1. So if we want to plot a box plot, we go to Graph, down to Box Plot. And for this very simple example, you can just select Simple, 1Y, we only have one column. Click OK. And here you can select C1, hit Select, and then click OK. So let's blow this up. You click up in the upper part of the plot. You can click the plus button and blow this up and move this down a little bit so we can take a look at it. So here you can see the box plot itself. So if you click on the box, you can see the information displayed. The first quartile is 120.325. That's the lower bound here. The median is 120.6. That's the dashed line through the middle. The third quartile is 120.9. That's this value here. Then you can also see the whiskers. There's one whisker at 120.1 down here. The other whisker is up at, let's close this box out here. The other whisker is at 121.3. So here you can sort of see how the overall data is plotted. You can see the median. You can see it's a little bit skewed, but there's a little bit more data up here than down here. But otherwise, looks pretty good. You can also see the interquartile range. That's the IQ range, 0.575. That's the distance between the lower and the upper. In my opinion, the histogram is the most useful of the three plots we're going to look at in this lecture. It's a very compact way of representing data. So first of all, to construct a histogram for continuous data, we must first divide the range of data into intervals, which are usually called class intervals, cells, or bins. Once the number of bins in the lower and upper boundaries of each bin has been determined, the data are sorted into the bins and a count is made of the number of observations in each bin. To construct a histogram, use the horizontal axis to represent the measurement scale for the data, and the vertical scale to represent the counts or the frequencies. Fortunately, Minitab makes this easy and takes care of all the details for us. So let's look at the example in Minitab, and I put up the example here, and we'll walk through in Minitab how to actually do it. But I wanted to keep this up so you can take a look at how to actually do it in Minitab, what commands to use. So the example is a quality control engineer needs to ensure that the caps on shampoo bottles are fashioned correctly. If the caps are fashioned too loosely, they may fall off during shipping. If they're fastened too tightly, they may be too difficult to remove. The target torque value for fastening the caps is 18. Engineer collects random data sample of 68 bottles and tests the amount of torque that's needed to remove the caps. So this data set is stored in this Minitab data set called cap torque. And I'll put it up on the Canvas website so you can take a look at the data set and you can plot it yourself. But you go to graph, histogram, and then simple. You can also do a simple fit, and I think that's what I did in the next lecture, the next example when I walk through this specific example, showing you how to do it in Minitab. So we're going to graph the torque versus the frequency. You can see the nice graph that Minitab puts out, It's and so this has a number of counts. So between in the bin that shows 16, you have 14 counts there. That's the most, right? But it is kind of skewed. It's not really. I wouldn't call it exactly normal. It's kind of skewed to one direction. So let's take a look at this exact example using Minitab. Let's take a look at how to plot a histogram in Minitab. So for this example, I've entered our information in columns 1 and column 2. Column 1 has the torque values, so that's really what we care about in this particular example. So to plot a histogram, let's go to Graph, choose Histogram. You have several options here. You can choose Simple, that'll just plot the histogram. You can choose with Fit, that'll try to plot a bell curve through your histogram data. Let's go with Fit. Click OK. Typically, the graph variable won't be chosen, so you'll have to select it. So let's select torque, hit select, click OK. Let's bring down our data so we can take a look at our graph. So here we can see on the horizontal axis is the torque, on the vertical axis is the frequency. You can see the mean, the standard deviation, and the number of particular data points here. You can see the bell curve that is plotted through the data. So it's a little bit skewed. It doesn't look exactly bell shaped, but it's pretty simple to plot histogram in Minitab. And in my opinion, the histogram is so useful, and Minitab is just awesome at plotting these charts. Once we collected our data, we're typically interested in obtaining the sample average. So let's suppose we have n observations in a sample. One of the most important measures of the central tendency in the sample is what's known as the sample average. So here we just divide the values divided by the number of values we have. This is simply the arithmetic mean. Another one is what's known as the variance. The variance sort of is a measure of how far each individual value is from the mean. So here's a formula for the variance. The units of variance are kind of difficult. They're actually the square of the original units of the data. So for example, if we're measuring lengths and it's in feet, variance is going to be in feet squared. But that's a little bit inconvenient and awkward to interpret. So usually what we do is we do the square root of the variance. And that's what's known as the standard deviation, and use that as a measure of the variability. The primary advantage of the standard deviation is that it's expressed in the original units of the measurement. Now, fortunately, Minitab again does all this for us and makes statistics a lot easier than what it would be if we had to do this by hand or even by using a calculator. So let's take this exact same example with the cap torques, and if you follow this example, I'll show you. It shows how to get all the statistics off of it. So once you load this data set, again, I'll provide this data set on the Canvas webpage. Go to Stat, Basic Statistics, and Display. Descriptive Statistics. In Variables, select the torque column. Click OK, and what you'll get out is you'll get this printout that shows exactly all the relevant information. So the variable is the torque. I think that's in the first column. There's 68 values. Here's the mean, 21.265. Here's the standard deviation. Here's the minimum value. Here's the first quartile. Here's the median. Here's the third quartile. And here's the maximum value. So very useful Minitab in doing all the statistics for us so that we don't have to do it by hand. All right, if you have any questions, just post them in the discussion groups.